are motion graphs. Motion graphs are usually something like meters on the y versus seconds on the x, or their, which is displacement over time, or their velocity, meters over seconds on the y, time on the x. They can be acceleration, meters per second squared, over time. The time is always on the x, and whatever your motion is, whether it's to do with distance, whether it's to do with velocity or acceleration, would be on the y there. Okay, there's a few tricks that we're going to go through, so I'm going to kind of go through some of the answers to these questions that they have here, and we'll see if we can give you some hints as we're going along. First question is, in which section is the car accelerating from rest? So this means this is a graph of some sort of car. You want to find a point where it's not moving, and then you want to see where it's accelerating. So that means that it has to be this is your velocity, so it has to be increasing in this direction. So this is pretty clearly that if I start right here at the origin, and then I move up to 12, my velocity went from 0 up to 12 meters per second, and it took 4 seconds. So this is clearly accelerating, right? You started out 0, you ended up 4. So when you see a velocity graph like this, anytime you have an increase like this, a flat line, in this case what it's implying is that it is constant acceleration. Okay, so the acceleration, we could just take the slope and we could figure out what the acceleration is. In this case, we could say it's 4, or it's 12 minus 0 divided by 4. So we could say the actual acceleration is a constant 3.0 meters per second squared. Okay, so our answer to that is A. Okay, in which section is the car's acceleration negative? Well, again, with that, all I have to do is just do my acceleration equation. And in case you've forgotten that, acceleration is equal to velocity final minus velocity initial divided by time. But I want this to be a negative answer, right? So in this case, my velocity goes from 12 meters per second down to, looks like 6 meters per second. So the acceleration would be negative. In other words, your final would be 6 meters per second minus our initial velocity of 12, so minus 6 for that, and then you would divide it by your time. So if it's velocity here, and you're looking for negative acceleration, you just look for something that's going on the downslope there. So that would be C. And then how far does the car travel during section B, so which is right here? This is kind of an interesting question. It's something I want a trick to reading these graphs. What I want is the distance from here to here. Okay, now when you're being asked to tell how far something is going, how fast something is going, anything like that where you have to do some kind of calculation with one of these graphs, we're looking for two things. We're looking for, can I get my answer by doing y times x? Does this equal the answer? Or can I do y divided by x? Does this give me my answer? Okay, and so with this one, how far does the car travel? Well, let's see, it's meters per second, and then it's seconds here. So if I take y, which would be meters per second, and I multiply it by seconds, look what happens with this. The seconds goes away, because meters over seconds, that equals meters. Which means that in order to get my answer to this, I need to multiply my units from y times my units from x. So in that case, if you have to multiply, what you're looking for is you're looking for the area under the curve. Always look for the area under the curve in that case. So here we go. Y times x equals area under the curve. This is important. Stop the video, write this down. You're going to need this going forward. Area under the curve. So how do I get my distance during section B? So this is my distance during section B. And I want area under the curve because I've decided that meters times seconds is going to give me meters. And so all I have to do is just get my area under the curve. So since this is just essentially a rectangle, I can just do length times height or width or whatever, and I have, it ends at 9, 8, 7, 6, 5, 4, so 1, 2, 3, 4, 5 times 12, so this is 60 meters. 5 times 12 equals 60 meters, okay? And all I did was I just said, okay, well, do I need y times it. Now, if you need y divided by x, let's say that I wanted acceleration for this, because in that case, meters divided by seconds is equal to meters divided by seconds squared. That's the units for acceleration. Well, in that case, you just use slope. So, okay, so if I wanted to know what is my acceleration from at 0 seconds to 4 seconds, I would just find the slope, and I would just go up here, and I would take 12 minus 0, as in y minus y divided by x minus x, gives me my slope. All right, and that's exactly what they're asking for in this next section. What is the acceleration of the car in each section? And so because I know that meters per second divided by seconds gives me my answer, and then y divided by x is equal to slope, I can go through and I can do a quick calculation of this one. So let's try this. We'll say y2 is 12, and we'll subtract out y1, which is 0, and we will divide that by x2, which is 4, and then x1, which is 1, and that is equal to 3 meters per second squared. Okay, so B, I'm going to do 12 minus 12 divided by, who cares, because 12 minus 12 is 0, so we know that my acceleration here is 0. Okay, and I'm not looking for the area, I'm looking for slope in that case. C, I'm going to take my original, or my final y, which is, looks like 6. I'm subtract out my initial, which is 12, and then my final time, which is 11, minus 9. It's going to be equal to negative 3 meters per second squared. Okay, and then finally for D, we're going up here, we're at, what is that, 10, and we're subtracting out, so that's for our y2, and then our y1 would be 6, so 6, and then we would subtract out 15 minus 11, so 15 minus 11. So this is 4 on top, 4 on the bottom, so this comes out to 1.0 meters per second squared. Oops, squared. So this is really important that you remember this. This is going to make your life a lot easier if you can remember that y times x equals area under the curve, y divided by x equals slope. All right,